So, hello everybody. Welcome to another exciting session of the Virtual Global Spine Conference. Today, I'm very excited to host Dr. Korchi, Dr. Amine Korchi. He's a neuroradiologist from Geneva here in Switzerland. So it's a Swiss-dominated session tonight. And he is so experienced in artificial intelligence that I invited him for a special talk about AI in spinal imaging. Dr. Korchi has had a radiology education in Switzerland and in Montreal, and he is very experienced also in startups, and he works as a CMO as well in part-time. And Dr. Korchi, may I say again, thank you very much that you're here with us tonight, and please start with your presentation.
Thank you, Alexander, for having me. Thank you, Ali. It's a pleasure to be here today and exchange with an audience of spine specialists. And I will talk about artificial intelligence in spinal imaging applications and product. So spinal imaging. Oh, before that, just some few words about my affiliation disclosure. I'm a practicing neuroradiologist in Geneva, Switzerland, in private practice, and I share my time between my clinical practice and as a chief medical officer of Cerebrio, which is a medical technology company based in Denmark. I have something to disclose. I am involved and shareholders of companies in the field of healthcare technology, including radiology AI company that are listed below. So let's begin this talk. Spinal imaging is by definition rich and multimodal. It is one of the specialties in imaging where you will need X-ray and MRI for most patients, and you will follow up these patients with different type of modalities. So it's a rich modalities, rich specialty with different type of images. Each image brings a specific information. Spinal imaging is growing. Its volume is growing faster because of the improvement of the accessibility of care, because of the development of new therapies, and also because of the development of technology and aging population. And this volume, the volume of spinal imaging, grows faster than the number of radiologists. And this gap is problematic because we are facing an unbalanced situation, and we will need the help of technology. During the last 20 years, radiology has completely been transformed by technology. The most illustrative example is speech recognition, the introduction of PACS and softwares that help us to improve our productivity. So we hope that technology will help us to also fill this gap between our resources and capability and the volume of imaging. And AI obviously is one of the candidate technology. So spinal imaging, beyond being a high volume imaging, is a challenging imaging. There is a high inter-reader variability. The error rate is significant, as it is in all radiology. It's approximately between 2 and 5%, depending on the studies. It can go higher also if there is additional phenomenon like burnout. As I said before, spinal imaging is a high volume discipline with repetitive tasks, repetitive type of reporting, and a fair amount of measurements. On the left side of the screen, I share with you a study which is illustrative of the complexity of spinal imaging. It's caricatural study. It's a case report. It was one patient who underwent a lumbar spine MRI in 10 different MRI centers in a 3-week period. And they compared the report for approximately 49 findings. Each finding is one abnormality in one location. And they found a very poor overall agreement between readers. The kappa was 0.2. The sensitivity of these 49 abnormalities was 56%, and the average miss rate was 43%. So this is very caricatural. Obviously, it's not the reality for all practices and all exams, but it illustrates how hard it is and how variable it is in this field of imaging. So artificial intelligence can help us improve all these issues. So what is artificial intelligence? Briefly, artificial intelligence, or AI, is a computer program based on mathematics and statistics that learns from data to solve specific problems. The most dominant form of AI that is currently used today is deep learning and convolutional neural network for computer vision. And it is what we call supervised learning. So these models learn by seeing a lot of examples of images and labels that are the indication of what is in the images. So it's not a very intelligent way to learn, but it is the dominant way to produce this software. It is what we call supervised learning. What artificial intelligence is not, so AI is not magic. Huh? It's not magic, it's mathematics, it's software. AI is not smart. Artificial intelligence is disciplined. It performs the task that it has been trained to. It is focused, but it is consistent, and it doesn't know what fatigues mean. And that's a very important point. It's not free. It has a cost of R&D, a very high cost of R&D. If you consider the level of investment in the venture capital field, it's billions of dollars that has been invested in AI. And also the cost to use these tools, because it's an additional cost to your practice as a radiologist or as a spinal specialist. And artificial intelligence is not replacing radiologists, at least not yet. AI is a very good way to boost your academic career. We have seen an exponential growth in the number of papers, publications in radiology AI after the year 2000. The top three countries that publish are the US, China, and Germany. And I think that we're just at the beginning of this boom of publications. So it's a great way to boost your academic career and advance it. What about the commercial offer, the softwares that are approved in Europe and in the US? So the commercial offer today is rich. This website, AI for Radiology, is an initiative to increase the transparency of commercially available software. So it's one of the most comprehensive database of AI software for clinical radiology practice that has a CE certification. It includes also product with FDA approvals. And today, this website, this database, has approximately 215 products. And in the market of startups, there are most probably between 200 and 300 startups working to develop this product. So the commercial offer is rich for this very young industry and in this very specific topic of radiology AI. In the search bar, when you input spine, you only find 5 products on this website. So those are the 5 products. There are all other products that apply to spine, but I think in the description, it's not written specifically spine because they apply to other organs. And we will see more example of these softwares and companies. So the commercial offer is very rich, and it's driven not only by conventional manufacturers who are also very active in AI, but strongly by small companies that we call startups. But this commercial offer is not mature. 36% of the product have a peer-reviewed evidence of performance or efficacy, just a little bit more than 1/3. Of this 1/3, just 1/4 of it has a publication that assessed the clinical impact. The publications are mainly focused on diagnostic accuracy and technical and clinical feasibility. And the pricing and the deployment, how you deploy it in your hospital, are very heterogeneous. So the authors of this article concluded that AI in radiology is in its infancy, despite having more than 200 products CE marked. And in this study, they reviewed 100 commercially available products. The focus of the clinical validation today, as you see on the chart on the left, is the diagnostic accuracy, not the clinical impact. It is also explained by the fact that radiology is concerned by diagnosis. And currently, we try to compare the performance of AI with the ones of radiology. But obviously, in the future, we will see more evidence about the clinical impact. So going beyond the diagnosis and looking at the downfall, the benefits along the value chain. So let's talk a little bit about the radiology value chain. So AI and radiology in general is not only analyzing images. We are not just looking at images and doing some measurements. Radiology is a service offered to patients and physicians and healthcare systems that begin first by the indication. When and for who and in which condition you ask for a radiology exam. After that, the physician order the exam to the radiology department. By the way, I do not like the wording order. I prefer request. So it requested to the radiology, and when the radiology received this request, they schedule the exam. Scheduling is not easy because you need to position this exam on the right machine for the right radiologist, etc., etc. So it's not an easy task, and it has a lot of complexity. After that, we need to put a protocol. Usually it's a physician, a radiologist, that write in the software, in the radiology information system software, or on the paper order, how to perform this exam, which sequence to perform. And those information are important for the technologists to perform, to realize this examination. After that, the patient comes to the radiology and we do the image acquisition. And the images are sent to the PACS, which is the storage system. And the radiologist then can open the exam on his screen, analyze the images, do post-processing of the images, for example, some measurements. And he will use usually a speech recognition system to describe the finding, conclude, give an impression, and validate the report, which is then communicated to the physician. And based on this report, the physician, orthopedic surgeon, neurosurgeon, spine specialist will make a clinical decision. Artificial intelligence is not only concerned by image analysis, it will impact all this value chain and will go step by step. So the first step, which is the indication and ordering, deciding when to do a radiology exam and which radiology exam, faces also some problems. We receive frequently inappropriate order, for example, an MRI when you should do a CT, or incomplete clinical information, this is very frequent, or even unreadable order, which are mainly usually written by hand. So AI could bring some help here through clinical decision support software that will help us and help the physician to identify the best exam to request to the radiology. Such guidance already exists in the form of guidelines like the appropriateness criteria of the American College of Radiology or the I-Guide of the European Society of Radiology. In the US, it will become, or I think it's already mandatory for a physician before ordering an advanced imaging exam like CT or MRI to consult a software that will validate his choice. So we are all going into this direction where software will be used as a validation process before confirming the order of a CT or MRI, and AI can definitely boost this evolution and make it faster and better. We can also use AI to automate the order, to analyze automatically the clinical scenario and produce the right order, the right request for the right exam. And AI can also be used to create summaries of patient health records. There are not a lot of companies and software working in this area. I'm not aware of a specific software based on deep learning, but there is ample room to develop tools and good opportunities here. So this is the first step. After sending the request to the radiology department need to schedule the exam and put the protocol in place. For MRI, for example, it's deciding which sequence to perform. Here we face a lot of problems, like patients not showing up at their appointment, inappropriate scheduling, meaning that you schedule a spine with surgical screws and material in a 3 Tesla MRI, while it's better to put it in 1.5 Tesla because you will have less artifacts. Or you put all spine MRI the day that the neuroradiologist or the spine radiologist is not here or is in holiday. So scheduling is not easy, and we're facing a lot of inappropriate scheduling, inappropriate case assignment, for example, allocating cases to non-spine specialists, and also workload distribution. We also face difficulty to staff to predict how many people we need, so under or overstaffing, and I think it's probably the same in other specialties. We face also suboptimal protocoling, so protocols that are too long or too short, particularly in MRI. And this task of scheduling and protocoling is time-consuming and error-prone. As a solution here, AI can predict no-shows. This has been published in, I think, in many times, that it is feasible to predict the patients that will not show to their appointment. AI can automate the scheduling and make it smart. It can also forecast the workload and to enable to better staff and better manage your human resources. It can also perform automatic protocoling. So AI is able to analyze the request and suggest the right protocol. This has been published, and some companies are working on this. For example, to decide if we need to give a contrast media or not. Keep in mind that in a busy department, protocoling will consume 0.5 to 1 full-time fellow per week time, and it's not insignificant. So automating this task will improve the functioning of the service. And AI can also be used to automatically perform the safety screenings, particularly for MRI, to screen for ferromagnetic or other risk factors. Some products and some companies working in this area. This company named Equium Intelligence, which has been recently acquired by another company, Rad AI. Those are American startups. Both have been founded by radiologists and have a strong radiology leadership. Has 2 products for scheduling and resource optimization. The first is Resource EQ. It's a software that will enable to forecast the workload and the volume of work. And by doing this, you can better allocate your human resources and you can better manage your plannings. The results are very interesting. I was presented with a demo and it was impressive. There has been also a lot of publication in this field of workload forecast, and that's a very, very interesting application, particularly for radiology. The same company has also a product named Schedule EQ, which enable to semi-automatically or automatically perform the scheduling and try to to allocate the right radiologist for the right activity at the right time, depending on the work volume, depending on the productivity of the radiologist, depending also on its specialty, etc. So this task is a very complex task, and if we can automate it, or at least have this software to support us, that would be a big relief and a big saving of time and resources. After scheduling and protocoling, then the patient comes to the institute and we perform the examination. Usually the technologists perform the examination and the image acquisition. And the problems here are also numerous. Examination can be lengthy like MRI. The quality can be disrupted by artifacts. There is a lot of manual and repetitive tasks by the technologist. There are risks for patients. Could be radiation exposure or the magnets. And sometimes the exam is incomplete and we need to recall the patients. So here AI has also a lot of opportunities to improve this. And most startups and most companies focus on examination and image analysis because this is the core of computer vision. Technologies that here acts are the denoising and super resolution, models that will reduce the noise of the image, make it better. Deep learning is also able to accelerate the acquisition of the image by factors of 2 or 4, and that is significant. If you can divide the time of acquisition by 4, it means that you can do at least 3 to 4 more patients. It's a big thing. AI is also used on CT to reduce the dose of radiation. It is also used for quality control and artifact reduction. And more impressively, deep learning is also used to create images, synthetic imaging, to create CT from MRI. And we will see some example. And last but not least, AI enable also to adapt the protocol on MRI while the patient is still on the machine, enabling to reduce recalls and acquire the right exam first time. Many companies are operating in this field. The companies that I show on the right side are just illustrative, are the one that has published papers or are unique in their value proposition, but it is not an exhaustive list of the companies. Let's take a look at some examples. Cerebrio. So Cerebrio is a company in which I'm the chief medical officer, and Cerebrio has a product named MR Smart Protocol. So it's a software based on deep learning that will analyze abbreviated protocols, so the first sequences of an MRI while the patient is still in the machine. And depending on what the software detects, it will suggest the next right sequences. And if there's nothing, then the protocol will be kept abbreviated. The benefits of this product is to reduce recalls, acquire the MRI right first time, and also to keep it short and to acquire only the necessary images. For lumbar spine, the example could be, a scenario could be to decide to give or not gadolinium. If the software detects an abnormality that necessitates gadolinium, then it will give the indication to give gadolinium. If not, then we will stop and not give gadolinium. So this is a software that will act at the point of imaging while the patient is in the machine. And the models needs also to be adapted because they need to be fast in order to have this information quickly. The second company I'm describing here is Subtle Medical. It's also one of the first and most productive companies in this field. They commercialize a product named Subtle MR. So Subtle MR is a software that performs denoising, and by denoising, it leads to acceleration of scans. So on the image, on the left side, you see a T1, which is one sequence of the lumbar spine that is traditionally acquired in 3 minutes. And on the extreme right side, you see a T1 that has been acquired in half this time, in 1 minute 40 seconds, with the same quality, if not a better quality, how is it possible? It is because this software will improve the quality. In the middle, you see the T1 acquired with a short time, but without the software, and you see that there is a decrease in the quality. So this software enabled to acquire low quality images faster, and it improves the quality. And this is a very smart idea. And at the beginning, I was a bit afraid that by acquiring low quality images, we will miss some information. But to date, the clinical validation and what I have seen shows that this technology can be useful, and it is safe. But we need to be cautious, and we need to follow closely the clinical validation and the long-term follow-up of this technology. Here we see a T2 sequence. On the left side, you have the traditional T2 sequence in 3 minutes. On the right side, the T2 sequence accelerated and improved by Subtle Medical in 1 minute. So it's 1/3 of the time. So that's a massive gain. That's a massive gain. Multiply this by the number of MRI that you have per day, do the math. That's a big thing. That's a big thing. That's a big improvement in productivity. One clinical validation has been performed in the US about this software of Subtle Medical, and they concluded that deep learning enables a 40% scan time reduction for spine MRI, while maintaining diagnostic integrity and image quality, and even exceeding the quality of the standard of care. So it's a thing to follow, to make sure we are not missing information with this software, but that would definitely transform how we operate our MRIs and the volume of patients that we can handle. The second case, yes?
I mean, may I ask you, can you go please one step back? Am I right? The truth in the traditional sequence, and when you do this faster protocol and then you add this software, do you still see the truth? What was done with the traditional? Why have you been afraid of this step?
So if you use the software, then you will see only the image on the right side. My concern is by acquiring a shorter, low quality image, we might miss some subtle lesions. And it's funny because the name of the company is Subtle Medical. So if you look at the traditional image on the left side, and if you look at, for example, the medullary cord, the spinal cord, the signal is very homogeneous, and if there was an abnormality here, it will be highlighted easily. On the low resolution without the software, you see that the signal is heterogeneous. And my concern is that here we might miss something if it's small. And that is the first concern. And the second concern is that the software might mask a small abnormality. So if you see this heterogeneity here, who knows, maybe there is an abnormality here that has been masked by the software. That was my concern. I'm not saying this is what the software does, right? Apparently, to date, I didn't hear any problem like this one, and the clinical validation goes in the right direction, but I think we should be cautious because this remains a kind of a synthetic image, and it is not the pure acquisition. Okay, I hope this answered the question.
Thank you.
So going beyond synthetic image, beyond denoising, this company, MRI Guidance, has commercialized a product that creates a synthetic CT image from an MRI. It means that you perform a cervical spine MRI, and you need, for a reason, to assess the bone structure with a better resolution, a better quality. Traditionally, you will call back the patient and you will perform a CT with radiation exposure. With this deep learning based software, they are able to create a CT image based on the MRI. And this company has also published their result in top tier journal, such as European Journal of Radiology. And in this example for cervical spine, the synthetic CT was non-inferior to the conventional CT for the visualization of bony structure of the cervical spine. They have also a product for the lumbar spine. They published also the result in 2021 with an equivalency between the synthetic CT and the conventional CT. And they also have for the pelvic bones and the sacroiliac joint. And you can see the images on the left side. Those are not CT images. Those are synthetic images created from MRI. The impact here is very important because you will save the patients from ionizing radiation. You will save costs. You will save also time. So that's also a very impactful technology. This company developed deep learning based software. There is also another technology that can give us CT-like images from MRI. The name of this technology is the Zero-TE. Basically, you capture the signal of MRI immediately after sending the first radio frequency pulse. That's what we call zero time, echo time. And it gives also a CT-like image with very good results. And some, I think one research team even combine deep learning with Zero-T. So again, the direction is set up here. It is probable that in the future, we won't need to do a CT if we have an MRI. We will extract the CT image from the MRI, and it's very useful for surgical planning. It's very useful also to look for subtle abnormalities like osteophytes in the cervical spine or erosions in the sacroiliac joint. So that was for the image acquisition stage and examination. After finishing the exam is sent on the PACS, and the radiologist opened it on his or her workstations, and he began analyzing the images or doing some post-processing or some measurements. The problems that we face here are the problems of diagnostic performance that is not perfect, the fatigue of the human radiologist. Reviewing images is time consuming, especially with advanced imaging with multiple sequences. We have a lot of repetitive manual tasks like measurements, and there is a significant inter-observer variability, particularly in spine. AI here brings solution in three main avenues. The first is abnormality detection, fracture detection, metastasis detection, osteoporosis, and lumbar spine stenosis. So detect abnormality, also to quantify them. AI acts here by doing automatic annotations like the labeling of the vertebra and automatic measurements. And AI is also able to extract biomarkers that are not visible to the human eyes. So this part of the value chain attracts a lot of attention of startups. And this is the one, by the way, that attracts the most attention of software developer, not the examination image acquisition. I apologize, I have made mistakes a few minutes ago. So this step of image analysis is the one where you have most of the products, because it is the core of computer vision, which is abnormality detection. There is a lot of companies and a lot of product in this segment. I present here only a selection of products. And let's begin with fracture detection, which is the low-hanging fruit. First thing you want to do in spine is to do fracture detection on radiograph. So Glimmer is a French company, and they developed a product named BoneView, which detect fracture. They began by limb fractures, and they also developed a model for thoracolumbar spine. So BoneView detect fractures of the vertebral plates, compression fractures, acute, subacute, and also chronic. This software has been tested in this study that I'm presenting here, that has been awarded a very prestigious award at RSNA in 2022. And they showed that their software improved the sensitivity per patients for fracture detection across all anatomic locations with greater than 10%. And that's a big thing, improving sensitivity by 10%. It means that you capture 10% more true positive for fracture. However, and this is very interesting, this improvement of sensitivity, this improvement of performance with AI was not present for thoracolumbar spine. So there were no evidence of difference between AI and without AI. And there was no evidence that AI provided a gain of sensitivity in the thoracolumbar spine. So this low-hanging fruit of fracture detection is not easy for AI, and this software, for example, doesn't perform very well. Keep in mind that the version that has been tested for this paper was, I think, the 2020 version. And since then, the software has 2 new versions. So it is possible that the new version are better. And all the product that I show you today are the first generation of product. We are at the beginning of this industry. So I expect to see a gradual, more or less rapid increase in performance in the future. So fracture detection isn't easy even for AI. This is another company named AI Dog from Israel. They developed a product for CT to detect cervical spine fracture and vertebral compression fracture. What's interesting here is that when they submitted the pivotal study data to obtain the FDA clearance to market their product in the US, they presented the result of a retrospective study with 186 cases, which contained 50% positive, 50% negative for cervical spine fracture. And their result was very good, a sensitivity of 91.7% and a specificity of 88.6%. NPV, which is the negative predictive value, 99%, and PPV, positive predictive value, 47%. That was the data that has been submitted to the regulatory authorities to obtain the right to market it in the US. And 1 year or 2 years later, an American team did a diagnostic accuracy and failure mode analysis of this software on their practice, and they didn't find the same performance. So they concluded that their institution, the software performed poorly compared to the data that were sent to the FDA. And the most important drop of performance was sensitivity. The data submitted by the company to the FDA showed a sensitivity of nearly 92%, while in this study, the sensitivity was 55%. So that's a big drop in sensitivity. Specificity was higher in this study, and negative predictive value remained very high. And this illustrates very well the problem of generalization. That is the first problem, that a model that has been developed on a database and then use it in another hospital, usually you have a drop in a performance. And the second issue that is interesting here is that the pivotal study of the company used a data set that contained 50% of fracture and 50% of non-fracture. While in real life, you don't have 50% fracture, 50% non-fracture. In this study, for example, which is a real life practice, they had 6.4% of fracture in their data set. And this also reflects the fact that real world conditions are different from clinical trials. And we should be cautious not take as granted the performance of these clinical validation study that has been performed in a controlled environment. Another interesting fact is that 50% of the acute fractures involving the transverse foramen were missed by the software. And we know that these fractures are very important to detect because they can injure the vertebral artery, and you might also change the protocol and acquire an angiogram of these arteries. And the software has also some difficulties with degenerative spine because it's a more complex spine. So there has a significant number of false positive of fractures. So it's a great example to illustrate the generalization problem and also the problem of the difference between the control condition of clinical trials and the real world condition that differ significantly.
Amine,
Yes.
may I ask you a question? When there's written this term deep learning algorithm, is this an ongoing learning process, or was this the learning process before the software was released to the market? So is the program getting better and better and better while you're using it? Was this study performed in the real world just too early? Do they have to run the system for like 2-3 years and then you will have the same sensitivity like in the FDA for the FDA clearance? What does deep learning mean? Is this ongoing, or was this before and then it stopped by release to the market?
Yeah, thank you, Alexander. That's a great question. So today, to my knowledge, when a software is released, you cannot improve the internal function of the software. So it's not a continuous learning. However, the authorities showed interest and long-term guidance that they will support this type of continuous learning. So today, when you commercialize a product, you have your FDA or your CE, you cannot modify the internal structure that will affect the risk of the product. In the future, most probably we will see continuous learning.
Thank you.
So another product by a company named SmartSoft that analyze images, and this one truly analyze images, is named Colombo. It's an AI spine assistant. It's a software that analyzes lumbar spine MRI and do an automatic labeling, automatic detection of all abnormalities that you find in the lumbar spine, or at least most of them, like central canal stenosis, foraminal stenosis, disc herniation, conflicts with the nerves, etc. And the software automatically creates a preliminary report that you see here on display. And then the radiologist need to correct, adjust, or he can copy paste the report. So from my perspective, that's a very interesting use case because it helps us cope with this very repetitive task of lumbar spine MRI. I have tested the product in a conference. It was on a fairly a good shape spine. So I'm looking forward to test it on a very degenerative spine to see if there are not a lot of false positive, false negative. But this value proposition is very seductive, and it could lead to a full automatization of the reporting of lumbar spine MRI in theory. I did not find a clinical validation published, and I would be happy to read it if the company send it to me. But on their website, they state that the software reduced the interpretation time by up to 48%, which is credible if they do the measurement and produce a report. And they state also that it reduces errors by up to 15%. So that's a very interesting use case: automatic detection, measurements, and creation of a preliminary report. Another use case and products are automatic measurements. So we perform a lot of measurements for spine. In the US, I think the most dominant measurements is the Cobb angle. In Europe and in France, there are also measurements on the sagittal plane. These are time-consuming tasks with a lot of variability between different practitioners. And automation here is definitely warranted. So I present here two companies, Glimmer, it's again the French company, and Image Biopsy Lab from Austria. So they perform automatic measurements for static of the lumbar spine, Glimmer on the AP and lateral view, Image Biopsy Lab on the AP view. And clearly this value proposition is extremely seductive because when you deal as a radiologist with these radiograph, most of the time spent on this case is measurements. So Image Biopsy Lab, they state on their website that AI can reduce reading time by 90%. And it's again, credible and possible because most of the time is dedicated to measurements. Measurements to automate it is challenging because you need to define some cutoffs from at which stage of angulation you activate the measurements. There are also variability in the cutoffs between teams, between different countries, etc. So it's not an easy task, but it's a very seductive value proposition. And I have a feeling that this could reduce our workload as radiologists and technologists. It also enabled the production of these standardized reports that are easy to read for the surgeon, the specialist, etc.
I mean, do you know whether this software works with hardware in situ too, when they are full of screws, like we love to decorate the spine? Do you know this the software works post-op imaging too?
That's a good question. I do not have the answer. I would be very happy to catch up with these companies and ask them. But that's definitely a great question to ask them. Thank you. So we're approaching to the end of the value chain. After reviewing the images and doing the diagnosis, measurement, then we need to create our report and to communicate the results. The problem we face here is that it's also a time-consuming task, very repetitive, a lot of manual tasks, error-prone, a lot of medical jargon, and the reports currently are static and textual. It's not interactive, and it's mainly texts. AI can bring solutions such as pre-field report, as we have seen with the company that commercialized Colombo for lumbar spine. They can also, the softwares can also offer structured report. It can convert free text report in structured report, which is also something very valuable for people that are not used to do structured reporting, but want to improve the quality of their report by structured reporting. AI solutions can automatically suggest the follow-up recommendation, and they can also generate reports that are patient-friendly and understandable. So few companies are working in this other extreme of the value chain. Most of the companies are focused on image analysis at the center of this value chain, few on the extremities. And here we find again RAD AI, but also two other companies named Smart Reporting and KeyDiag. So Smart Reporting and KeyDiag are companies developing software to create structured reporting. So those are not a stricto sensu AI companies because the software are more rule-based. It helps the radiologists do structured reporting with illustrations. However, these companies, they will integrate the result of AI automatically in the report, and they will also use this structured report to train new AI models. So they are more or less very well connected to the AI ecosystem. RAD AI is a pure deep learning company, and they have developed a product for reporting, which is RAD AI Omni. So when the radiologists report the lumbar spine, L1, L2, disc herniation, blah, 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 the software listens to the radiologist and create the conclusion, which in the US, you call the impression. So it automatically creates the impression, and the radiologists only have to review it and correct it. And that's a big gain of time. It's a big gain of time, and this is most welcome today in radiology. So not only it automatically creates the impression, but it's also by listening to the reporting of the radiologist, will suggest the right follow-up according to the guidelines. This is less applicable to spine. It's more for lung nodules, for example, or thyroid nodules. And they go the extra mile by offering another product named RAD AI Continuity, in which this product will make this follow-up happen. So it will do an automated scheduling for the patients, communicating with the patients, etc., etc. So this company, RAD AI, focus on what we call non-interpretative AI. They are not concerned by image analysis or computer vision. They are focused on solving problems that are around the image interpretation. And these steps are also time consuming, and these products are welcome. So we have made an overview of the radiology value chain, and what we see is that AI has the potential to improve every step of the value chain. So from my perspective, AI will change the face of radiology. AI will change completely radiology. Radiology in 15 years will not be like radiology today. And many problems that we're facing today will be solved. Maybe we will have other problems, but there will be a deep transformation by AI. And when you see this, you wonder, will AI replace radiologists? Because when you look at software like Colombo, which is intended to analyze a lumbar spine MRI and produce the report, and the natural evolution is to do this independently, or at least to do most of this job. So will AI replace radiologists? I think you all know Geoffrey Hinton. So he's a famous professor of computer science and AI in Toronto. He's named the godfather of AI, so a prominent personality. And in November 2016, he shocked the radiologists by saying that people should stop training radiologists now. That was in 2016. He said that it's just obvious that in 5 years, deep learning is going to do better than radiologists. And this marked a lot the history of radiology, because a lot of trainee or medical students, they just said, I'm not going to do radiology because deep learning will just replace it. That was in 2016. So now we are approximately 7 years, 6.5 years later. And Geoffrey Hinton was interviewed a few weeks ago, 25th March 2023, on CBS about AI. And the presenter asked him about radiology and his prediction. And he said he was wrong. He said he was wrong. It's going to take 10 years, not 5. So he still believes that AI will replace radiologists. I personally do not think it will replace radiologists. It will change our job, and we will certainly reinvent ourselves and find a way to bring value to the healthcare system. But he persists. He thinks that it will not take 5 years, it will take 10 years. So we still have few years, according to Geoffrey Hinton. And on the website of SmartSoft, the company that commercialized Colombo, there is a frequently asked questions section. And I was very surprised, and it's funny to read this question: is a radiologist needed anymore? And their answer to this is that radiologists will be needed for at least the next 40 years. So having read that, I'm less stressed. I think I will sleep tonight, because in 40 years I will most probably not being a radiologist anymore. But just to illustrate this idea that AI might replace radiologists, I don't think it will replace it, but who knows? Who knows? We don't know how fast it can evolve. My impression is that we're here to stay. We will just reinvent ourselves and bring a value in a different form, always related to diagnostics and imaging, but only the future will tell us. So what's the future? I think, Alexander, you summarize it well in your bucket list for AI. So I think the future is AI doing things that humans cannot do. Today, AI is mimicking humans, detecting fractures, doing measurements, doing the protocols, adjusting the protocols. The future is when AI will do things that we cannot do, like doing the aging of a fracture on a radiograph, or differentiating between different type of tumors, or the consistency of herniation discs. So this is something that would be really revolutionary, because it's not anymore a workflow play. It's not just helping radiologists or competing with radiologists. It's creating new science and impacting patients' income strongly. So I'm arriving at the end of the presentation. The take-home messages is that AI in spinal imaging and in radiology is in its infancy. We are at the beginning of this revolution. It impacts the entire value chain. The current focus is on image acquisition, make it faster, make image beautiful, acquire the right protocol at the right time, abnormality detection like fracture detection, measurement and workflow. There is a potential for improvement of quality and productivity, job satisfaction, and patient safety. There is a potential, but it's still not realized, but we are going toward this direction. The challenges are numerous for massive adoption, the generalization, as you have seen with cervical spine, fracture, clinical validation, the trust of physicians, IT and workflow integration costs, etc. Startups are major actors along traditional manufacturers, and that is my final words. And I would be happy to discuss this topic with you.
Oh, thank you. I mean, thank you very much, Dr. Korchi. This was a fantastic talk. I learned so much, so many new features. I didn't know actually that AI starts a lot more on the left side of the value chain. I was always focused on imaging and imaging analysis. I mean, Dr. Al-Gaddafi from Libya, he's a neurosurgeon, asked whether there's a protocol for osteoporosis on MRI. Do you know, is there a company offering software that puts out any kind of T-score for us surgeons?
Thank you for this question. So osteoporosis, there are software detecting osteoporosis on CT, and that has been used for opportunistic screening on all the CT that are performed. I'm aware of publications trying to identify a biomarker on MRI, but not a product.
Okay.
And that is
another
an
question.
Interesting topic.
Yeah. Another question, because we're running out of time. Do you think that the AI will help more the younger radiologists or the more experienced radiologists? Who benefits the most now, and what do you think? Where is the journey going to?
That's a great question. So I think that young radiologists will benefit a lot from AI, but there is also a risk that they can fall in the trap, and if AI is wrong, they will just copy AI. So a big caution here. It's important to be very careful. They will benefit if the software is very performant and if there is a good supervision of human radiologists. What's very, I think, interesting to notice, and my opinion is that the young radiologists in training, if they learn to practice radiology with AI, they will not be turned back. In the future, they will need AI. It's like me. I learned radiologists with speak dictation. I will not come back to writing report by hand. For the older physician, I think that the more older you are, the more performant you are, the more oiled your mechanism of doing radiology is, and it's harder to adopt a tool. But it depends on the personality of the physician, and it depends also of the added value of the product. So for older radiologists, I think it's a mix. But for younger, my impression is that younger that learn radiology with AI will not be able to do radiology without AI in the future.
Yeah, I think so. The same in with every technology we use in the OR as a surgeons. It's the same. I don't want to miss navigation. I don't want to miss this new technology stuff. may I ask you a question? Why or where are the big companies? Where are Siemens? Where is GE? Where is Philips in this field? Are they waiting like sharks? Which startup will be doing best, and they will catch these, or do they do their own R&D in the background? But we're not talking about them.
So manufacturers are also very active in AI. Startups are more visible. Startups are more focused on abnormality detection, on very innovative value proposition and use cases. Manufacturers are focused on elements that are core to the image acquisition, like, for example, image acquisition acceleration. They are also very active, and I think recently there has been a study analyzing the publications or the regulatory approval, and they found out that manufacturers have a lot of regulatory approvals and patents on AI, so they are active. They are just doing different value proposition than the startups, and I think ultimately they are very complementary with startups. And we have seen recently some acquisition, and we are at the beginning of this collaboration.
Okay, thank you. Dr. Korchi, Amine, thank you very much. Merci beaucoup.
My pleasure.
Formidable. It was so nice having you here. And we have always some topics. We have to repeat the topic again because of great steps forward. And I bet I will invite you again in a couple of years. And then we will have a big laugh about the presentation you gave us today, because everything changed a lot more rapidly as we expected. Dr. Korchi, thank you very much that you gave us this extraordinary lessons. In the chat box, everybody was really excited, and we will meet again next week here on the Virtual Global Spine conference on social media. We will tweet about the next topic. And thank you all over the world where you're listening to. I was really delighted. It was a great session. Thank you, Dr. Korchi. Thank you, Amine.
Thank you for inviting me. Have a good evening. Good night.